Welcome back to Unpacking Ideas, and thanks for joining if you're new here. Today we're going to be unpacking the book A Mathematician's Apology by G.H. Hardy. Helping me unpack this book today was Brian Allen. Brian is a professor of mathematics at Lehman College in the Bronx, New York, and he leads discussion groups in New York City around the subject of philosophy of mathematics. In our conversation today, we talked about Hardy's bio and some context for the piece up front. And then we got into Hardy's defense of mathematics. We talked about the permanence of mathematical discovery, the beauty of mathematics in terms of aesthetics. We talked about Hardy's concept of seriousness, generality, and depth. Then we got into the differences between applied and pure mathematics, mathematical reality versus physical reality, and the unintended consequences of mathematical discovery, as well as the moral responsibility of the mathematician. This is the first piece I've done on the podcast about the subject of philosophy of mathematics, and personally, I think it was a great piece to start with. It doesn't require that you have an advanced understanding of mathematics, but it still goes really deep and gets into some very rich terrain. So I enjoyed this conversation a lot. I learned a ton from Brian. I hope you guys do too. Here it is, my conversation with Brian on A Mathematician's Apology. Thanks for coming on.
Yeah, thanks for having me. This is great.
So we met a couple weeks ago through a mutual friend. Shout out to Ryan for bringing us together. And you were telling me you teach math for a living, right? That you're a math professor?
Yeah, I'm a math professor at Lehman College, part of the city of New York in the Bronx.
Cool. And you were saying, you're obviously very interested in math, but also very interested in philosophy. And you were telling me, I thought it was kind of funny, you were saying you've been kind of setting up these meetups around the subject of philosophy of math, and almost nobody comes because it's like the math people aren't into the philosophy and the philosophy people aren't into the math. Is that kind of how you see it? And
yeah,
why do you think that is, I guess?
I'm not exactly sure, like with this particular group, sometimes I'm not sure like what draws people out. Mm-hmm. But certainly, I think some of the philosophy of math texts are very technical. Mm-hmm. In general, philosophy of math is difficult because you have to have a pretty good knowledge of mathematics.
Yeah.
But you also have to have like a philosophical bent and have a pretty good, deep understanding of philosophy, and you have to be able to combine those two things. So you're like already getting rid of a lot of people, just by requiring those two strengths, right? And then... and it was, pretty technical stuff, but...
Well, the math would definitely scare me away.
Right.
But do you think the philosophy scares the mathematical people away? Like they kind of feel like, I don't know, like who has time for this speculation bullshit? Like I want to see the proofs. Is that kind of the thinking with a lot of mathematicians? Or
I think so. I think there's this sense that in philosophy... you never really answer questions. And I should say, I believe that actually is pretty true about philosophy in the sense that like we've been asking these same questions since, the time we've written things down. Right. And so there is this feeling of like, we're never really going to answer them in any kind of definitive way. And we're just going to talk a lot, but it has very little value in like the long-term scheme of things. This is going to get to some of what I think Hardy has. There's not like the same permanence of like, I discovered something and I know that like, even if I die and everything changes, like this fact is still somehow true.
Right.
But to me, like philosophy is about asking questions that as a human being, I find, how could you not ask these questions? And it's like, even if I can't answer them, it just feels like a part of being human is to ask these questions. And, if philosophy can do nothing more than to just give me a better landscape of what the possible answers are, that to me is worthwhile.
That all makes a lot of sense. And it seems that Hardy would have been one of these people that would kind of have no time for philosophy and speculation. Like he was very much interested in proofs.
Yeah. He was a little confusing in here because certainly the way he starts the essay out, it's like, he immediately starts by deriding like anyone that wants to talk about a subject, right? Basically any critic of any kind, he's just like, is a second-rate human being or something like this.
Yes.
So he starts out, and then, so I think that's saying like philosophy is, not as important as actually doing mathematics. But then he's confusing because later on he says something like, I may have been a pretty decent philosopher. Like, I'm a better mathematician, but like I might have been a decent philosopher is like something else he could have done.
Oh, yeah.
And even the fact that he takes a position on, maybe we're getting too much into the text now, but he does, I'll just say generally, like he does take a position on this philosophy of math question of ontology, like what are mathematical objects. I think maybe that's more of a product of his time period, that they're a little more open to make those things. But I think generally speaking, when you ask mathematicians now, like they're going to be very agnostic towards this question, and maybe not even very interested in like, like this, why are you asking me these kind of questions kind of thing.
Sure. Yeah.
But, Hardy is willing to at least take a stand one way or the other.
Maybe we should talk a little bit about who he was and the stage of life he was in when he was writing this. So this was written towards the end of his life,
right?
In 1940, and it definitely has a bit of a melancholic feel to it. I think his friend who wrote the foreword even called it like a haunting. What is it, like a haunting sadness?
A book of haunting sadness. I mean, it's a long quote, but I like this. He says, it's witty and sharp with intellectual high spirits. Yes, there's crystalline clarity and candor are still there. It's a testament of a creative artist, but it is also a passionate lament for creative powers that used to be and that will never come again. I know nothing like it in the language, partly because most people with a literary gift to express such a lament don't come to feel it. It is very rare for a writer to realize with the finality of truth that he is absolutely finished. And that, I mean, I think that is like throughout the essay, this undertone of like, what do I do now? Like what
he felt like his best days were behind him as a mathematician, for sure.
Yeah. And Hardy is a very successful mathematician. He's famous for, in particular, two big, collaborations. So one with Littlewood, and then who's another mathematician in England but came from South Africa, and then Ramanujan, who is this interesting prodigy from India who's born into a small town and does not really have much formal math education, but reaches out to several mathematicians with letters, and eventually and he gets lucky that Hardy somehow looks at it with a careful eye. Most of these other people get this letter in the mail. This happens today too, not to me. I mean, I'm not famous enough, but like, people get these emails about like, oh, I think I solved this, or I think
people thinking they're like an undiscovered genius kind of thing.
Yeah. So, I mean, just statistically speaking, most of these people are not undiscovered geniuses. So you start getting biased towards like, okay, like most of this is nonsense.
It's just another troll writing me kind of thing.
Right. And so it's interesting that Hardy, I don't know how many of these letters he's getting or not, at that time, but he chose to take a closer look, and eventually him and Littlewood realized like, wow, there's something like here.
Well, and he took the gamble and brought Ramanujan over to Cambridge and worked with him for several years, and they published some famous papers in mathematics and
And we can come back to that, but I think also, just Hardy had a very successful life. He was he was a bachelor. He seemed to just really pour himself into his mathematical life. And I don't know this too carefully, but I suspect that he really enjoyed that. Like, I think he probably really enjoyed that life of just being a mathematician and having these people that he respects, that he works with, and I'm sure that brought a lot of meaning and enjoyment to do that. But, what we see here is just now he feels like he can't do it anymore. And we can't answer this question, but it does bring up a question to me, like, is that actually true? Or is this somehow like a self-fulfilling prophecy that he has? Or he just can't do it quite at the level that he was doing before, and he just can't accept like just a slightly, I don't know. I get the sense that,
is there actual justification for the claim that math is a young person's game?
Yeah. There's a lot of these famous stories, and he brings them up, of like really famous, really important mathematicians that died young. I mean, these are interesting stories, but I don't know how much we want to glean from those particular people. And he does seem to use that as, I mean, listen, I think generally speaking, yeah, of course, like on average, you're going to do your better work probably in your 20s, 30s. But you know, that's the thing with averages. Like you don't want to let that change who you are as an individual per se. And, because you know, there's many examples of mathematicians who have been very successful up and through their 70s and 80s, which again, you know, maybe they were just lucky to have a certain body or brain that allowed them to do that, but maybe also they were just nimble enough to like accept the evolution of like what that role looks like as you get older, right? And maybe Hardy, again, I don't want to say this with too much confidence, but maybe he just wasn't willing to accept like the evolution of, you know, what his role could be.
Yeah, that's a good point. And I also remember reading that he did have a bit of a health scare. I think it was like a blood clot going to his heart, which prevented him from playing cricket and some of these other things that he loved. And I think he also thought that maybe was the reason that he could kind of no longer do mathematics like he used to. So that maybe it was a bit of aging and also a bit like health related as well. And I think it's also kind of brings us a little bit back to when we're talking about philosophy. You know, he starts by kind of asking some of these like existential questions. Earlier he says, my defense of mathematics will be a defense of myself. He says, anyone who defends his subject will find that he is defending himself. And my justification of the life of a professional mathematician is bound to be at bottom a justification of my own. I think it's important to talk about this because the bulk of this work is him trying to give a defense for mathematics and justify that mathematics and pure mathematics has value. But in a lot of ways, the reason that he's invested in that project is because he's trying to justify his own existence and the way that he's chose to live his life.
Yeah, it's interesting, right? Because he's really asking philosophical questions. I feel like about like why, how should we spend our time here on Earth? Like, what's the meaning of life? But then more specifically to him, like I spent my life doing pure mathematics. Was that a valuable thing for me to do? And this also brings up his point in the beginning of like, okay, well, he says something like, most people can't do anything well, right? Which is this quote that really alienates basically most people who are reading it. But I like this analogy to the Olympics of like, you know, when I watch the Olympics, I don't expect to be there at any point in my life. And I don't feel any like disappointment in myself because I'm not Olympian, right? So I think in that sense, I can read his paragraph and be like, okay, sure. Like most people are not going to be at the Olympics level of whatever they do. Mm-hmm. So yeah, okay, I agree with you on that point. But then there's this question of like, if you are really talented, do you have some responsibility, you know, to do that thing? And Hardy seems to, I don't know if he ever says it super definitively, but he does seem to. Oh,
he does say it definitively.
Okay, yeah. So he does seem to be like, yeah, definitely. Like if you have a gift. But I don't know that he ever gives like a philosophical account of like why that is.
You're right. He doesn't. He says, quote, if a man has any genuine talent, he should be ready to make almost any sacrifice in order to cultivate it to the full.
Right. And my question to him would be like, is that ultimately going to be good for the individual? Or what is it philosophically that's making you feel like that is optimal or necessary, right? Because this is where I think these are very interesting philosophical questions, but they're very difficult to answer. But there are these like intuitions that we have as human beings that like, oh, if you have this talent, I think a lot of us feel that way. Like this basic intuition that like, oh, you shouldn't waste it. But I think philosophy is about challenging those kinds of assumptions. Like, are we sure that that's a good idea? Like, is that person going to have a good life, and is it really going to like advance the rest of us in any way, or should that person just make a decision about what they're going to enjoy or not enjoy, right? And I think in Hardy's case, like I think he probably really enjoyed his life, And so it's easy maybe for him to be like, yeah, you should also do this, right? But then, there's some Olympians that maybe they don't, right? Or maybe like that career ends at 24.
Right.
And
Maybe
you're
they
like,
wanted a childhood, a normal childhood, where they weren't just like in the gymnasium every morning.
Yeah.
Yeah.
And I don't have anything like concrete to say here, but just to like bring up the question of like, I don't know.
Well, yeah. And this it makes me think a lot of the movie Good Will Hunting, which is very much inspired by Hardy and Ramanujan's relationship. And that movie brings up a lot of these themes, where you have this kind of undiscovered math genius and you have this professor who is very much like Hardy, a bachelor who's kind of dedicated his life to mathematics, obviously very gifted. And he is very much in the camp that Hardy is in, which he's basically saying, it would be a shame if this guy were to not kind of cultivate his gift, and he's such a genius, like the world would really miss out if he were to just kind of get drunk with his buddies and kind of enjoy his life. And then you kind of have the foil of that, like Robin Williams' character, who's kind of more advocating for personal happiness and relationships and love and all of these things. So it seems to me that Hardy is very much in the camp of, if you are somebody who has this great gift, then you should kind of, like he says, he even uses the word sacrifice almost anything in order to cultivate it to the full, even if that means, a family or, kind of a more traditional path to happiness.
Right. I love this movie. And I also love it in part because of what you brought up, this tension between just like this raw talent and just trying to cultivate it. But then to me, like Robin Williams' character makes this entire movie, and he's such I love his character, and there's such a deep emotion and reflection that he has, and that whole story about his wife and how he doesn't make it to the Yankee game, I think, right? Or maybe it was a Boston game.
Yeah.
Which is funny because the Yankees are in the World Series right now, so
Yeah.
but the emotions that you feel in that scene, it's like that's what you want from a movie. And so like I, as a mathematician, are like really happy that there's a movie that involves mathematics in a very substantial way, but also like gets at these very deep emotions and these philosophical questions.
Absolutely. Yeah, and actually Hardy and Ramanujan are mentioned in that movie. There's a scene where he's the math professor is kind of explaining what we just explained about the kind of discovery of Ramanujan.
Right.
But yeah, I mean, and I think why it's relevant to this piece too is, again, this is Hardy kind of towards the end of his life, kind of asking these existential questions of like, did I live my life right? Did I invest my time in the right things? And that kind of brings us into his justification of mathematics.
Yeah, so now you can read the middle part of this essay as just, like you can take it out of this broader context we just put it in and just read it as two ways, right? I think it's, he does a good job of just explaining what the community of pure mathematicians does, what they're interested in, how they operate, like what they find interesting versus non-interesting. And he does a good job of putting it in the broader context of like physics and engineering and like these other areas that use math but are not necessarily the same. But
Right.
of course,
Yeah.
the end goal in some sense is to try to use this to justify or give an account for why he did what he, or his life. But I think the first thing that he comes to is this. There's this permanence to mathematics, and we'll see that when we get to some examples. But when I think about when people ask me like, what is philosophy of math? Like, what's that about? I think this permanence aspect is part of it, which is like, math seems to be this human endeavor that is concrete or universal in a way that, and permanent in a way that almost any other human study is not. Of course, to actually give an account of that is very difficult, but at least in the experience of doing mathematics and looking back at history, there's something very permanent about these ideas. Facts that were discovered in BC times are still facts now, and that's not really true in almost any other subject in the same way. So there's already this question of like, why is that the case? What is it about mathematics? But from Hardy's point of view, this permanence is somehow drives his interest in doing mathematics. Like he feels like he is, and I think a lot of mathematicians can feel like they're plumbing the depths of something permanent.
Yeah. Maybe I'll read a few quotes on this and you can kind of riff off.
Yeah.
He says, quote, Greek mathematics is permanent, more permanent even than Greek literature. Archimedes will still be remembered when, I don't know how to pronounce this, Athulcius is forgotten because languages die and mathematical ideas do not. Immortality may be a silly word, but probably a mathematician has the best chance of whatever it may mean.
Right. When you say immortality, there's 2 points here, because if these mathematical objects are somehow in some Platonic realm where they actually just like exist, whatever that means, then it brings up questions of like, what does he really mean by immortality? Because maybe we discovered some fact about it, but if these mathematical objects exist in some universal sense or some real sense of ontology, then the discovery is in the sense of you brought it into human knowledge, and that's very important to us as human beings. But its immortality somehow was already there, right? You see what I mean? Like,
right. It was kind of discovered rather than kind of invented or conjured up out of thin air. Basically, the idea that it was already there. Somebody just kind of discovered it.
Right. So the immortality comes from the fact that it's I don't know if I like the word immortality. I like the word permanent here, though he does use both, as you mentioned. The permanence, though, is the fact that you discovered something that's not going to change because society changed its point of view about something, or culture changes, right?
Or language change or whatever.
Right.
Yeah.
Right.
Well, but I do think it's interesting that he uses the word immortal. Again, not to kind of psychoanalyze Hardy too much, but it reminds me of this idea of kind of like a immortality project. I think the first I'd heard of this idea was in The Denial of Death by Ernest Becker. But his idea there is that, as humans, we kind of have this need to leave something behind that will kind of outlive us. For a lot of people, that's children. But that could also be a book that you write, or in this case, a mathematical theorem that you discover, or, some advance that you make in your field. And it seems to me here, he's very much kind of in love with this idea of mathematics being the ultimate way to leave behind something that is permanent and immortal. And I think he is right about that. In almost any other thing that you can do, history has a way of kind of erasing that or changing that. Like even when you look at a lot of the scientific discoveries that were made around the time that Euclid was kind of coming up with his theorems, they're almost like no longer relevant because they've kind of been adapted. And
yeah, the permanence of scientific knowledge, well, I don't know if permanence is the right word, like it had influence, right? But it's not, science is evolving in a way that math doesn't seem to be evolving in the same way. Don't get me wrong. If you go deep enough into philosophy, there's always somebody willing to like represent almost any point of view. So there are people who challenge this claim that like, oh, math does go through a lot of revolutions similarly to science. But I think even when they challenge it, I think there's clearly differences in the way that math has evolved as a field versus science. Like, a good example is going from Newton's theory of gravity, which is still used in a lot of like engineering and things because it's accurate enough in most of the cases that we care about. Mm-hmm. But Einstein's theory of gravity is certainly more correct, and we know that this is the correct theory. But, sometimes you just don't need that level of... You can accept a certain error that Newton's theory of gravity has in the particular application. You don't need this other theory. So, that's how science can kind of like almost get like a deeper understanding as time goes through, and we replace one theory with another and get sort of closer to the truth. But, some of these proofs that I think we'll get into very soon here haven't changed. Like, I still present these proofs to my students, and the facts haven't changed either.
Yeah, that's helpful to kind of get into the nuance of it. Maybe before we get into, beauty and some of the other things, we can talk a little bit about some of the examples he uses of mathematical proofs.
Yeah.
Yeah.
I think this is really important because, again, you need some example to try to sink your teeth in here, and also for us to kind of ground the conversation a little bit. He gives two examples. And the first one is Euclid's proof of the existence of infinitely many prime numbers, right? So prime numbers are things like 2, 3, 5, 7. We can't break them down into a product of smaller numbers where we exclude 1. So something like 6 can be broken down into 2 times 3. So that's not prime. And at some point he says something like this really beautiful quote about how the primes are the raw material of mathematics, and Euclid's theorem tells us that there's plenty of raw material to do mathematics. I mean, that's just a nice poetic way of describing it. But yeah, the statement is that there are infinitely many prime numbers. This brings up the beauty, I think, to some degree. Hardy says something like, there's no space in the world for ugly mathematics or mathematics that's not beautiful. It's funny when he says that because I have the sense that, like, I'm also a mathematician, and I don't know that Hardy would find anything that I've done beautiful. I'm also not sure that he would, I'm fairly confident he would lump me in the category of people who don't do anything well. And I'm completely comfortable with that. So I can say that with a smile on my face.
Yeah, well, I think Ramanujan is maybe the only person who's not in that category in Hardy's book. So
Hardy's level
of well is
pretty high. Yeah, so I'm completely happy not to have cleared that bar. Or I'm okay.
Once
completely
in a century
comfortable.
Genius. Yeah,
right. But I think the reason why I'm bringing that up though is because I'm not going to claim that what I've done is beautiful to the math community. I'm not going to try to make that claim. But I will say that I've enjoyed it, and it's been beautiful. Like, there's something there. Do I do feel like I'm being creative in some way? I don't know that I would put it on the same level as like an artist or something like that, but I do feel like a sense of similarity to like artists in my life or creative people. There feels something there that like jives with me as a person. And so when I'm reading what Hardy's talking about, even though I know like to him he's talking about a different standard, I think he is like touching on something that I am drawn to about mathematics. And even as a teacher, like when I teach that there's infinitely many prime numbers, there's this like feeling that like, okay, to me, this is like in some sense, like obviously compelling, right? But of course, I also, because I've taught long enough, know that what I feel is not how people feel when they hear this, not how everyone feels when they hear this, right? And so, beauty is relative, but also what you find beautiful, what you find compelling is a very much says something about your personality and what, and so it's hard to separate these things.
Well, and there's many aspects of beauty that he goes into. Maybe we could zoom in on one aspect and kind of relate it to this this proof of the infinite number of primes. So one aspect of beauty is kind of aesthetics. And he talks about there being like 3 qualities of aesthetics in a beautiful math theorem. One of them is unexpectedness. The second one is inevitability. And the third is economy. So I think with the theorem that you just brought up, it definitely checks the first box of there is a certain unexpectedness.
Yeah, I think there is a certain unexpectedness. I mean, it's hard because there's this experience of when you've seen and gone through the proof enough times, of course, it's not unexpected
anymore. Then you begin
anymore.
to expect it, yeah.
So you lose that experience. That experience happens the first or second time you see a proof of something, right? So, but in that sense, maybe it's a good example because if you're coming to this and it's fresh, it's new for you, then you can have that experience by going through this proof possibly that I maybe can't have anymore. But I do have with things that are being developed right now.
Well, and the other example he uses in the book is the square root of 2
right.
being an irrational number. And maybe that's even a better example of kind of a unexpected, there being an unexpectedness there.
Yeah, let's get back. Well, but hold on. Can you go through the other two? What were the other two again? It was unexpectedness.
Inevitability and economy.
Right. So it's interesting, the tension between unexpectedness and inevitability, because, okay, those seem to be like, against each other. But I think, again, it's experience, right? So the first time you see the proof, there's this unexpectedness. Mm-hmm. But then after, what the proof does is, even if you're like a naysayer, you're like, no, there's no way there's infinitely many primes. There's just no way. What I think we find so beautiful about a proof is that it's universally compelling in some sense, right? Mm-hmm. Like if you read this, you may go into it like, there's no way. You're like completely biased against this result. And yet, if you really read the proof carefully, you will be converted. And that's not really true of most other things. And so there's something really...
You're kind of forced to accept it.
Yeah, it's inevitable, right? Like it doesn't matter your bias. I mean, okay, let's be honest. Like biases matter even in mathematics community. But let's just like zoom in on this particular in one theorem and one proof. Mm-hmm. I think you can go into that result with whatever bias you have, but if you really follow the logic, you're going to be compelled to believe at the end.
Well, and as somebody who is, not a mathematician, right, and somebody who's guilty of telling mathematicians that I suck at math, like I will say that my experience with this after, watching a few YouTube videos, it was very similar to like seeing an optical illusion,
right? Where,
they tell you, okay, look at this picture and there's 2 images that you should be seeing. Because like in this case, they're telling you kind of the answer at the end. So you just have to, actually look at the proof to understand the answer. And I found that, I was watching these YouTube videos and really trying to get it for, close to an hour. And then it clicked. And once it clicked for me, it was like I could see it.
Yeah, I think I like the way you just described it. I'm glad that you because I should have asked you, because it's interesting to see from somebody who doesn't do mathematics all the time. But you just described the process, I think, of doing math at every level, right? It's like when you first approach something new, it's often very difficult. You're like, what the heck's going on here? And you have to slog through it. But and I tell this to my students, like if you're willing to invest and slog through that, there is usually this moment of like a light bulb goes off and you see it. And that's when it goes from where you have this experience of maybe unexpectedness, but then it goes to this inevitability. And it's those light bulb moments, you'll hear mathematicians talk about this, I think is like the drug that keeps you coming. It's but a lot of doing mathematics is the slogging through calculations that are maybe not extremely interesting and trying things that don't work. And it's like any creative process, I imagine, there's a lot of time spent banging your head against the wall. And as a human doing that, it's hard because sometimes you want to, like you spend a whole day doing something, and at the end of the day, it feels like it didn't mean anything. And it's hard, right, to like look at a 8-hour day and decide whether it meant something or not, right? So there's this like bad maybe reflection of trying to figure out whether 8 hours worked. But over a long period of time, you have no idea like what that 8 hours did to the long-term progression of your thought. But anyway, to bring it back to this, you really described, I think, the feeling that people have of doing mathematics. And maybe we can go into, what were you going to say?
I was going to say too, yeah, I mean, he even calls that, I think, like puzzle solving delight or something like that. But what were you going to say?
Well, I was going to take us into the proof of
the other proof. Yeah, let's talk about that. Yeah.
And then all these other things will come into place, hopefully.
Yeah.
So the other one is so square root of 2. In one sense, it's a number so that when you square it, you get 2, right? That's what we mean when we say square root of 2. The number which, when squared, is equal to 2. Of course, I don't want to say too much about this, but geometrically, you've probably seen this, a right triangle with side lengths 1, and then the hypotenuse is length square root of 2. So there's like, in the history of mathematics, these triangles are, of course, important just for like engineering point of view, but also there's like the pure math question of like what is going on here, right? But okay, so to put this in context, though, It's possible that we call like rational numbers are the kind of numbers that you learn when you learn about fractions, right? And so, I mean, I don't want to say this trivially, but like a lot of people struggle with fractions, but I think everyone will agree that somehow fractions are simpler than maybe these higher level mathematical objects. So it'd be nice if all we needed to do engineering and physics was rational numbers, right? If the side lengths of every triangle was a fraction, this would actually be really nice. And in the history of mathematics, the Pythagoreans set up this whole like mystical belief system about like these rational numbers. They expressed them differently, but they're essentially the same idea. And at some point, they're studying these triangles and it has this hypotenuse of length square root of 2, and it's discovered that square root of 2 is irrational. So meaning that square root of 2 cannot be represented as a fraction, no matter what numerator or denominator you pick. And this is, again, a good example of like this naysayer attitude that you can go into a proof with, like, I think every number is rational. You can want that to be the case, but the proof, by the end of the proof, if you follow the logic, now you're compelled by the inevitability of the fact that square root of 2 is not rational, and now you have to pick up the pieces and deal with that fact. So let me just say a little bit about the proof, not the details, but both of these proofs are by contradiction, right? So that, I think, to a mathematician, and personally to me, is there's something very beautiful about a contradiction argument. Sometimes we prefer a direct proof over a contradiction argument philosophically, but there is something very like pretty about a contradiction argument. So in order to prove this, you're going to say, well, let's assume square root of 2 is rational, right? And the other one, you're going to say, let's assume there are finitely many primes, which, if the proof goes through, is going to be incorrect. And it's interesting because then the rest of the proof, you're basically working with something which cannot exist. Right. But you're able to still say things about it logically and then get to a conclusion. Get to a contradiction. And when you get to that contradiction, now you know that the original statement is correct. But there's something really odd about that when you think about it, because that means all the beautiful stuff that you did there is somehow not actually talking about anything that could actually, it's just like a story, or it's an argument that gets you to the conclusion.
Awesome. Well, so now that we've kind of laid out these first two proofs that he uses as examples, these two theorems, maybe we can talk about this aspect of seriousness.
Yeah, I think so for Hardy, he uses this example of chess versus mathematics. I think chess is, for him, an example of something that maybe everybody's had some experience with, whether you have a deep appreciation for it or not. I think he's assuming that everybody knows the rules of chess, which is probably a decent understanding. But his point is that, like, if you're reasoning about chess, and there's a certain sense that he's saying you're doing mathematics just by reasoning about chess. You have to there's one thing if you're just like picking the next move, then you're doing it in kind of a random way. Maybe that's not doing mathematics. But like if you're trying to look 4 or 5 moves down the road and trying to like plan out
some strategy,
all that strategizing is what he's calling mathematics here. And I think I see what he's getting at. But his point is just that, like, from a beauty standard, I think there's not like a seriousness to that. Here, I think we have to be careful. Like, there is a seriousness if you want to be a really good chess player, if you want to devote a lot of time to be good at chess. But for him, like, he's talking about from the mathematical point of view.
It's really not important beyond the scope of chess.
Right.
That's kind of the idea.
Yeah, you're bringing me right to it's like it lacks this immortality or this permanence. I mean, in some sense it doesn't, right? Because, okay, if you find a move in chess, then in some sense it's true that maybe it's a good move, but the problem is, I guess, are people going to care about chess, when society changes things like this? It doesn't have that permanence to it. It also is not the kind of thing you expect to affect other areas of mathematics. Like your facts or insights about chess, you don't expect to, like, later on make insights to I don't know, some completely different area of math. Or
quantum mechanics has
Yeah.
changed because I found this great chess move. Like,
Right.
yeah, that's not going to ever happen.
Right, which takes you into like some of these other qualities that Hardy identifies. So one of them is depth, and I think this is a very important. There's depth and generality, right? And what he means by general is like, for instance, let's use the example of square root of 2. Okay, so now you've proved square root of 2 is irrational. Square root of 2 has some a very important significance because of this triangle. But then it turns out you can prove that the square root of any prime is irrational using basically the same proof. And actually you can prove the kth root of any prime is irrational. So there's already this ability to, that's generalization. So you can generalize the proof from square root of 2 being irrational to this whole host of numbers being irrational. Actually, when I teach this, I do the square root of 2 proof in class, and then I have them prove the kth root of any prime is irrational because it's that similar. It's a good exercise for the students it's similar, but it's not exactly the same. And so it's a good kind of like test of whether you understood the proof. And so that's the kind of generality that he's talking about. And that is the kind of generality that like mathematicians are definitely drawn to. And, going back to seriousness, if like some of the most beautiful events in mathematical development are like when two very different areas of mathematics are linked in some way usually by some like very, big titan in the field or something. And like the ability to link what seem to be like such different areas of mathematics by some bridge is in itself like just such a beautiful experience to see that bridge being made. But then there's always with that a mine of gold that you can mine of new results when you use that bridge to get different insights. And so there's a seriousness to a statement when it can bridge and those gaps and this kind of generality. He also talks about depth, and there's something really interesting there too, because it's the so for instance, he talks about how proving that there are infinitely many primes is not actually a very deep, is not deep in this way. He says it's still a very beautiful theorem. That's why he brought it up, but he just wants to contrast. And he says it's not deep because in the proof, so this is a statement about the proof, not so much necessarily the theorem itself. He's saying that you don't really need to go beyond divisibility and the natural numbers to prove this. So it doesn't need to like plumb into deeper levels of mathematics to prove it. Whereas he brings up this example of the prime number theorem, which I'll say if you want to really dig deep, you can Google this. There's lots of things out there. But basically, now that there's infinitely many primes, you might start asking more questions about the primes, like how do they grow? Like, do they they probably get sparser and sparser, but can I be like more careful about like the rate of growth of these prime numbers? And so that's the prime number theorem, which is something that Ramanujan, I think, claimed to or tried to say something about that I believe was the thing that Littlewood showed was not quite correct his first time around, but then they wound up proving something very significant about it. And anyway, I'm getting a little off, but the prime number theorem is a good example because, again, it's a statement about prime numbers. So all you need to understand in some sense is divisibility and the natural numbers to make the statement. But in order to prove it, you have to, he says something like, plumb the depths of our deepest understanding of the theory of functions. And what he's talking about there is like you need to use a lot of calculus and analysis, which in some sense, it doesn't feel like you should need those tools to say something about natural numbers and divisibility, but it turns out that the proof requires it. And so, and that's an example of depth, a theorem that has depth. I think the other thing to bring up that Hardy brings up here is, you should keep in mind that no engineer is ever going to need to use all the digits of square root of 2 or really need to use the fact that square root of 2 is irrational, or at least I don't want to make too strong of a statement there, but the point that he makes is that like a large enough approximation of square root of 2 will probably be like some fraction with a denominator of like 10,000, which is probably already more than we need. Yeah, possibly. Is probably more than we'll need ever, at least in the next century or I don't know how many years. And so you know, you can ask me, then why should I care, right? Like, why should I care about the square root of 2? And in some sense, I don't know that there's not a practical answer. There's not like a utility per se answer. That's why I think we go to things like beauty and permanence, and there's some fact about square root of 2 that it is irrational, that I can't debate about anymore. And
yeah, I mean, well, I guess I just wanted to echo some of the things you said. You know, we kind of started by talking about the aesthetics, and then we want to say, okay, well, it's more than just pure aesthetics. You know, if we're making the argument that math is beautiful and worthwhile because of the aesthetics, then we could say the same thing about chess or even Sudoku puzzles. But he wants to say, no, it's more than that, because there's these other elements of generality and depth. And, you know, when you make a mathematical discovery, it has effects on different branches of mathematics and science and so forth. But then, like you just kind of mentioned, you then run into this next kind of problem, if we want to call it that, which is a lot of this this kind of pure mathematics doesn't kind of have this practical utility in the real world.
Yeah, this reminds me of one more philosophical point I want to make that's going to be useful here, that I think is well illustrated with the square root of 2. You know, this inevitability, this feeling of inevitability when you go through a proof like that and then see it many, many different times in mathematics, I think has this effect of making you feel like these mathematical objects are living in some Platonic realm. Or, you know, I find I don't always love the Platonic analogy per se, because it doesn't feel very modern, but that these mathematical objects like have some real ontology to them, and you know, I don't want to be too specific. And it's interesting because Hardy takes a stand on this, a philosophical stand, on saying that he believes that mathematical objects are real in some sense, and they live in some realm, and he's not very more specific than that. He also mentions that, okay, you can plug and play whatever philosophy you want, and everything I say will still apply. But I do think it serves more of a role than his like dismissive sentence seems to make for him, in the sense that like he says at some point that like the mathematical reality is more real than physical reality.
Yeah.
I mean, I love this sentence because it's very provocative. Like, what do you mean? Like, I mean, certainly as a human experience, I feel like this table is more real than, you know, because can I read
that?
Yeah, of course.
He says, I will state my own position dogmatically in order to avoid any minor misapprehensions. I believe that mathematical reality lies outside us, that our function is to discover or observe it, and that the theorems which we prove and which we describe grandiloquently as our creations are simply our notes of our observations. This view has been held in one form or another by many philosophers of high reputation from Plato onwards.
I think part of his point is that mathematics is about discovering facts about that world, the mathematical world.
Yeah, mathematical reality.
And not about physical reality. Yes, you can use these pure mathematical facts to say something about the physical world, but that's probably an approximation of the truth, right? There's also philosophical positions you can take there, but I take the position that that's always approximation of what's really happening in the physical world. And he mentions philosophically, we've never really given a Loctite account of metaphysics and how and what we're even saying when we talk about these physical things. So he's not a naysayer about science. I mean, he's definitely going to be on the side of rigorous science, but you know, his point is just that that's not what a pure mathematician is doing.
Gotcha. Maybe we can introduce this argument of harm. One of the things that he argues is great about pure mathematics is it's in some sense harmless, whereas, you know, applied mathematics can be used for good, obviously, you know, extending human comfort and happiness, but it can also be used for evil and warfare and all these things where he makes the argument that a real mathematician has his conscience clear. There's nothing to be set against any value his work may have. Mathematics is, as I have said at Oxford, a harmless and innocent occupation. The trivial mathematics, on the other hand, has many applications in war.
Right. This is interesting. He's made some quotes in this that are sort of famous. for being provocative, and also a lot of people disagree with his claims about math being harmless. But I think it's very important for his own psychology or his own feelings about what he did. And, I think this has a lot to do with, he talks about math as a form of escapism. He also talks about like imaginary universes are so much more beautiful than real ones, right? And I think, and I think there's something universal for, I think, creative types here. I think like, I think all creative types somehow spend a lot of time in this other world, whatever that means, right? Like, and somehow that more creative and idea world is somehow more satisfying than like, the real world in some sense. I think that's what he's trying to convey. And I think that is true for a lot of mathematicians. I like to describe it, there's this like playground of ideas I get to play in. And most people don't get to even see that the playground exists in any like real significant way. And I don't get to see it in the way that Hardy did, but there's this world that I get to like play around in and discover and throw sand around and, and have fun. And somehow that's there is an escapism aspect there. But now we come to this part of the argument where we have to, ask the question though, okay, yeah, I am doing it as like an escapist maybe. And I like this imagining or this real world of math, but in this sense, I'm talking about the mathematical world. But is there some unintended consequences to what I'm doing that I don't expect? And should I feel some responsibility for that? And certainly, I think in the history of mathematics, if you look at various different famous mathematicians, you will see different reactions. In particular, Grothendieck is a very famous mathematician after Hardy, who also like did some very significant work, but is also partly famous for later on in his career rejecting the pursuit of mathematics because he's worried about the implications that what he's doing will have
like unintended
on the world.
Consequences.
Yeah. And he seems to really believe that even though he's working in this like very abstract realm of mathematical thinking, he seems to disagree with Hardy, and he really seems to think that there's going to be some real consequences to this, even this like very abstract stuff that he's doing. Yeah. Hardy seems to have the opposite feeling, that somehow, and I think what Hardy's trying to do is, again, this example I gave you before, like, you never really need all the digits of square root of 2, you're not really using the irrationality of square root of 2. So I think he's trying to be like, what I did is this sort of perfect, these facts about square root of 2 being irrational, and what is being used in war is like the 10 digits of the approximation or something. And I get what he's trying to say there, this like separation he's trying to make. And I think, when it comes to Grothendieck, you can say the same thing. Like, oh, come on, like the things that you're proving are so abstract and they're so up in the sky. Like, are they really going to have an effect on, atom bombs or things like that? And I mean, the truth is we just don't know. Yeah. And I think maybe Grothendieck was, I want to be too specific. I'm using these examples because they're good examples. Yeah, but I don't actually know how he felt. But like maybe he felt like the fact that you don't know and you can't say for sure is enough, and of a responsibility that you have to like take that seriously. I mean, we're not going to answer this question, but it is somewhere where I think Hardy, famously, people say he got this wrong. I bring this up. The apology was written. This essay was written in 1940. The atomic bombs were dropped in 1945, and Hardy dies in 1947.
Well, I think it just brings up the moral question. I mean, like you take like the atom bomb, and you can kind of ask, well, who is responsible for, the deaths of Hiroshima? It's like, was it the pilot that dropped the bomb? Was it Truman who ordered the bomb to be dropped? Was it Oppenheimer who was head of the team creating it? Was it the mathematicians who came up with the theories that allowed the atom bomb to be made? You can kind of go down, and I think where I don't know that there's a great answer to the question, but Hardy at least wants to say, he's kind of drawing a line in the sand of like, the mathematics, the kind of pure math that we're doing is not like even if somebody is to take this math and kind of do something horrible with it, like, we've kind of got our hands clean here.
The ethics are very murky when you start trying to figure out like who's really to blame here. I mean, the Manhattan Project's a little bit different. If you were specifically there, I think you're not acting as a pure mathematician, and no matter what your whatever your job title is, like you're making a very conscious, you're making a very direct decision to be involved in something that and so that's a different ethical question than something you did being used unintended way.
Two thoughts. I'll let you take this wherever you want. One is, there's kind of a side argument he makes earlier on in the book about this kind of fallacy of what drives innovation. And that, like, a lot of times people think that it's, the scientist or whoever kind of sees a need within society and then, kind of invents the thing to fit that need. He guys says that's actually not what happens. What happens is people are driven primarily by three things. One, their curiosity. Two, basically their desire to do good work. And then three, reputation, status, everything that's connected to that, power, money, sex, everything like that. So it's kind of the case that a lot of times innovation will come about because, somebody is just kind of following their interest or, doing what kind of stimulates their curiosity. And then, this thing will be created, and then later different uses for that thing will happen.
Yeah, I think this gets at Hardy's point too. I think that, pure mathematician is engaging in a form of escapism and studying this real world, but not the physical world. And I think he's saying that that's why you have your hands clean. But I think maybe to your point, you don't know, just because you're only engaging in this like pure world of real mathematical objects or something, and just like the inventor, maybe like I imagine all these like creative types that are interested in like understanding these things are having that experience to some degree. Like Hardy's saying, they're just curious and they're like living in this ideas world and they're putting things together. But yeah, that doesn't, either you as the inventor then are going to have to find a use because you need to make some money, or someone else could come along and use it, and you just don't know how someone's going to be inspired. So, there's the ethical question of how much blood you have on your hands kind of thing that I think is hard to answer. But one way to try to say something about it, though, I think is there is a difference, I think, between, I brought up like actively working in the Manhattan Project, where I think a lot of those people were just curious too. Like they're like really good physicists and engineers and, all kinds of different people there. And they are just interested probably in curiosity. I mean, it's like cutting edge stuff. If you know about this kind of physics, like you want to be on the front lines, and maybe you're not thinking about the ethics. But maybe that's a different, where maybe you do, you should have had some ethical thoughts, or you do have some blood on your hands, versus maybe when you're doing something that was just like purely ideas, and then someone else applies it that you didn't expect. Like, I don't know what the ethical valuation is, but there at least seems to be an intuition that there's a difference there. And I think you brought up, when we've talked about this before, the example of AI researchers, which I also think a lot of them are very motivated just by curiosity.
Yeah.
I also think there's a lot of money interests there that are hard to tease out the difference between. It's hard to tell who's just a curious person and who's really just wanting to make a lot of money. But I think that's another scenario where it's hard to say how much blood on their hands they will have or not, going forward. Right. But it's certainly a much more direct thing that you're involved in than, proving that there's infinitely many primes or something.
Maybe we can wrap up where he wraps up, which is he gets a little more personal in this last chapter.
Yeah.
And I was thinking we could actually just maybe read the last couple paragraphs and talk about it.
Yeah.
I'll just quote here. He says, quote, "There is no doubt that I was right to be a mathematician, if the criterion is to be what is commonly called success. My choice was right then if what I wanted was a reasonably comfortable and happy life. But solicitors and stockbrokers and bookmakers often lead comfortable and happy lives, and it is very difficult to see how the world is the richer for their existence. Is there any sense in which I can claim that my life has been less futile than theirs? It seems to me again that there is only one possible answer. Yes, perhaps, but if so, for one reason only. I have never done anything useful. No discovery of mine has made or is likely to make, directly or indirectly, for good or ill, the least difference to the amenity of the world. I have helped to train other mathematicians, but mathematicians of the same kind as myself, and their work has been, so far at any rate as I have helped them to it, as useless as my own. Judged by all practical standards, the value of my mathematical life is nil, and outside mathematics, it is trivial anyhow. I have just one chance of escaping a verdict of complete triviality, that I may be judged to have created something worth creating. And that I have created something is undeniable. The question is about its value. The case for my life, then, or for that of anyone else who has been a mathematician in the same sense in which I have been one, is this, that I have added something to knowledge and helped others to add more, and that these somethings have a value which differs in degree only and not in kind from that of the creations of the great mathematicians or of any of the other artists, great or small, who have left some kind of memorial behind them.
Yeah. In that lament, I take it he's looking for this, like, I mean, I liken it almost to like what a human's looking for from religion, like something so universal and that feels like true in the
like true in the eternal sense.
Yeah, like, it's like he's trying to give a defense or a foundation for math in this like eternal sense that, again, I think is very human. It's like what we ask. Those are the kind of questions we ask in philosophy, but those are the kinds of questions that we haven't ever answered. And if that's what you're going to try to answer at the end of your life to create meaning, then, you're in, shaky territory, I think. And in that sense, I find it very unsatisfying. Like these last two paragraphs end very abruptly as far as like, if I try to take this as an actual apology, and I can't help but read it as like, a little bit sad that he felt like, I want to be careful here, but it does feel a little sad to me that like he felt like he needed this, this sort of backdrop to make his life have significance. I mean, part of why I find this essay interesting, I mean, I have some tension about it, like how interesting I find it sometimes, but I think it is interesting the same way that Good Will Hunting is interesting. It's not just a rote sort of defense of it also comes with this existential questions and these philosophical questions.
Yeah, I mean it has what's the word he uses? It has depth and generality.
That's right.
And that, I'm not a mathematician. I'm definitely not going to do any of the this kind of highbrow math, but there are many themes, getting into metaphysics, getting into reality, also getting into existential questions. What is a good life? What things should you focus on?
Yeah, it's about a mathematician's life, but there's something universal about just people who find themselves in a creative field or just find themselves dedicated to something. Maybe it could be science or art or music or whatever it is that have this passion. I think it's very transferable. And I really like one of my favorite shows is A Chef's Table, and every time I watch an episode of that, it's just like a different chef showing their life and their pursuit. I'm not a chef. I do like to cook, but I think as a human being, I'm identifying with just the experience of like working really hard at something, really believing in something, and wanting to be recognized to some degree, and wanting people to appreciate the new ideas and not just wanting things to be done the same way over and over again. Whether or not I'm actually doing that with my life or not is a different question, but certainly I relate to that experience. And I think that's maybe what's relatable about this essay is, he does consider himself a creative artist, which maybe is an unusual way to hear a mathematician talk about themselves, but there's something powerful there. And I think a lot of us do, at least in some sense, feel that way about the pursuit.
I definitely do.
Yeah.
Yeah. Well, this was great.
Yeah.
Thank you, Brian.
Yeah, this is very good. I appreciate it. This is like I always wanted to be on a podcast, so I appreciate the opportunity.
Heck yeah. Awesome. Hey, this is Zach. Thanks for listening to Unpacking Ideas. If you're enjoying the podcast so far, be sure to follow it so that you get notified every time I release an episode. And if you're listening on Spotify or Apple, I'd really appreciate if you could take a few seconds to rate the show. This really helps with the algorithm so that more people can discover it. Also, if you would like to get in touch with me or to hear about what's coming up next on the podcast, visit unpackingideas.com/podcast. And there I post links to books and essays that we'll be discussing on future podcast episodes. All right, that's going to do it for today. Thanks so much for listening, and I will see you next episode.